Good evening. My name is Gabriel Garcia, and I am working with my group members, Kristen Lazo, Alejandro Navarro, and Justin Boho for the Tech 4740 project. It all started with this pioneer. His name was Hans Olaf Nilsson, and he's a Swedish engineer who designed an off-the-grid house, as we can see in this article in the beginning, where he converted his roof into a harvesting center for the sun, which he took that electricity to power his home. As we can see in this other picture, this is the side where all the panels are set up. And he even has thermal panels on the side of the house, which are harvesting the energy in the form of thermal heat to heat up his home in Sweden. This is another picture of his house and the construction. As you can see, all the sides of the house are being used to harvest the sun's rays. And he uses this ceramic construction so that his house has a reduction in the need for insulation. It was a project that took much time and much thought, and Hans Olaf Nilsson definitely became a pioneer because he created a house that could run itself throughout the year. As we see here, he has his electrical system set up. He produces and stores hydrogen in his house as well for when the house needs extra juice and there is not enough sun. He can rely on hydrogen to power his home. He does that with the fuel cell, which in using an electrolyzer, he gets to store the hydrogen for later uses. And our goal that was given to us by our professor, Dr. David Blackman, was to recreate this house and design it with different components. And we were given the setting of Alaska, which is what led us to this project here. And we picked Anchorage as our setting because we feel like it has more sunlight compared to Gothenburg, where the original hydrogen house was built. In our journey, we decided to explore the house and try to create a small, simple diagram here, which gives us the general idea of what's going on in this house. It has a heated pavement, has a hydrogen storage, it has electric harvesting from the sun's rays. So, we continued to compare the two seasons and realized that, we had enough sunlight to make a successful house with the given parameters. So we continued to compare the systems and create replacements for this new house that we would hypothetically be building. Here you can see that the solar modules and the companies we chose, how we matched the power and total rated power and got similar annual production rates. Here's a picture of the solar panel that we hypothetically would be using. We did the same thing for the inverters. We found something similar that could be used in this new house in Anchorage. This is a depiction of the one we would use. Then we went on to the battery and thermal water systems. So here we have the lithium ion batteries, which is an upgrade compared to Hans Olaf Nilsson's house because lithium ions last way longer. They have more cycles compared to lead acid batteries. And for the water storage, we pretty much kept it the same. It's the same amount of water being held and readily available for the house whenever it's needed. Also, we needed a heat pump for the house and a heat exchanger, which take care of all the heating needs of the house that we would build in Anchorage, Alaska. That is the electrolyzer, which is used to produce hydrogen in the house. So we found something similar, which would also produce hydrogen in this house in Anchorage, Alaska. And here's the power module, the control modules. This is where all the decisions are being made in our house in Alaska. There are some hydrogen storing tanks, which have to be special to be able to contain the hydrogen. Typically, it's put under 300 bar of pressure. So these are different compared to the water storage, since water storage tanks are not being exposed to such pressures. We have our calculations for the houses, and we even provided a fuel cell, which we would hypothetically use in our house as well, trying to match the PS5 power cell, which was used in Gothenburg, Sweden, which is a very good operating fuel cell. And we also obviously need a compressor for our hydrogen. And this is just a depiction of that compressor. And we selected a Toyota Mirai as a car that could be used in this house because there's a surplus in hydrogen, especially since our house would receive more sunlight. That means that we would have a bigger surplus in hydrogen as backup, so we could use the Toyota Mirai. And we continue to study the safety standards needed to make a house like this. And we expanded on these regulations to make sure that our house could properly be built and be safe for the people to use. Yeah, hydrogen detectors are definitely necessary since hydrogen leaks is one of our biggest problems, or could be our biggest potential problem. And the last part of this project was to create a brochure, which we proceeded to start with our cost data lay symbol here, symbolizing that we are students taking on this project. And we open up by explaining that you can save the environment, that promotes the feelings of individualism. And our solution is off-grid homing, which there is not a necessary category for these types of houses yet, since it's a technology that's being developed, but it's something we feel will definitely be used in the future. So with the innovative solar technologies and hydrogen fuel cells, we get power for the home in Anchorage. So again, we bring up our little diagram just to get a clear picture of what's going on. We continue to expand on the most important systems that are placed in the house, which are the photovoltaic system, which is harvesting the electrical energy from the sun. We have the thermal energy system, which keeps the house cozy even in the coldest winter days and can defrost your driveway. Lastly, we have the hydrogen fuel cell technology, which is keeping that hydrogen stored for when we need it. And lastly, we shout out the sponsors and offer a website for more information, hoping that our viewers will be convinced and will look into this for a future in their home. And that's how we tackled this project by Dr. Blackman.